Five, and a five.
All right, number 5. We're talking about domain. Domain is what again? X values. Domain is X values. Talking about the X-axis, talking about the picture, not the axes. We're not saying that our whole entire domain is from -3 to 4, although it could be. What we're just saying is wherever the picture is. Yes, sir. We'll talk about that, yeah. Range goes bottom to top. Once again, we're not saying from -3 to 2. We're just saying wherever my picture is. That's what domain and range is all about. Talking about the picture. Okay, so domain, where do I start?
-3.
Start at -3, I agree. Where does my picture end?
4. 1.
Ooh, lots of people think different things. Some people say 0, looks like 4. The answer is 4. Here's why. Since this is like a filled-in dot and this is an open one, the filled-in one's like the big brother sticking up for the little brother. Since we have only one value right there, it's okay, we can continue on. It's not a continuous function, but it is a function nonetheless. One last thing, do I need parentheses, brackets? What am I doing here? I do parentheses here, bracket there. We use parentheses when we're dealing with open circles right there. We use brackets when we're dealing with filled-in circles, like here on 0, 0, or anytime we have just nothing drawn, no open circle visible, we assume it's a closed circle. It's an arrow if it's a infinity sign.
I see why you want to have a dollar count.
Yeah.
Doing it while you're teaching.
Yes.
Okay. I
Yes,
think
I'm recording right now. Hold on.
I apologize.
Hold on. Where is it?
Paul, you're going.
Alright.
What's the whole arrow here?
Alright, the arrow, so if we have an arrow, we're going to use parentheses. Because that goes on forever, and so that's always dealing with infinities.
Oh, you mean like the...
Like, yeah, so if our graph, like that, we use infinity with parentheses. Cool?
That's a terrifying arrow.
Indeed. Alright, our range, we go bottom to top. So, from the bottom, where does my graph start? -1. And at the top, it ends at +1. Now, once again, the big brother thing sticks up for the little one. So even though I have an open circle here, I got a closed circle or something like that there, closed circle or something like that there. So I'm okay. So I'm going to use brackets on both of them. Question.
No.
Alex?
Where's the mic? I don't realize my voice is
Any other questions?
I feel offended.
Comments, concerns?
Like, questions we can do together?
No, it's not number 5. Question about number 5. All right, let's move on. Gravy. All right, let's go to the back then. Let's talk about number 8. What is the parent function for number 8? No. It is cubic. Cubic looks something like this. If you didn't know that, you might be in trouble for tomorrow. It's cubic because I have an x cubed right there.
Where?
Right, it's a cube, the highest power. All right. Does the cubic parent function, or this one that I have drawn, does it have any type of domain restriction? In other words, are there any like x's I can plug in here that are going to make the graph not visible, be imaginary, anything like that? In other words, can I plug every x I can possibly imagine in there?
Yes.
I can. So that means my domain is going to be what? All real numbers, so make infinity to positive infinity, or just all real numbers. Either way. Questions about number 8?
No.
Okay. 9 and, let's see, 9, 10, and 13 kind of all look the same. We have square roots. I'm going to do number 9, 10, and 13 kind of work the same way. So number 9. What does that graph look like, by the way?
Square root.
Square root of,
Just have a line.
yeah, okay, I think I know what you're talking about. Like this guy right here?
Yeah.
Cool. What's my domain restriction for that? Or what's my domain in general for that picture?
It can't go below 0.
It cannot go below 0. So one might say
0 to infinity.
0 to infinity. Okay, I have parentheses there. Is that accurate?
Yes. No.
I can take the square root of 0, so actually it's going to be from 0 to infinity, including 0. Let's just say we didn't know what that picture looked like. We'd have to start plugging in numbers. Can I plug in 5? Yes, I can take the square root of 5. Can I plug in 10? Absolutely. Can I plug in negative 10? No, I can't. I can take the square root, that's where the I thing comes into play, but we can't graph I on an axis. So I can't take the square root of negative 10, I can't take the square root of negative 2, can't take the square root of negative 1. So that's why we just say from 0 to infinity. No negatives, right, right. I'll get back to number 10 and 13 in a second. Let's go to 11. Number 11. What is the only rule about fractions that I cannot have in the bottom? Can't be 0. So what numbers in the bottom of number 11, hope you're paying attention, can I not put in? 0. So that means what for my answer? Okay, can we use negatives? Can we use positives? Can we use 0?
So they're not equal to 0.
Okay, negative infinity to... Okay, that's one way to say it. All right, we'll do that first. And then what? Cannot equal 0. That's one way to say it. Who's got another way?
Isn't it parentheses?
All real numbers, except x can't be 0. Got another one.
Isn't it where you do negative infinity, comma, 0, parentheses, u, parentheses, 0.
Well done. Those are the three that I can think of. That's all saying the same thing. I would say that this middle one is probably the quickest and the fastest way to write it down. There's no like math race, so it doesn't really matter which one you do first or how long it takes to do a problem. But number 11, as far as this goes, that would be all the possible answers. Okay, for 10 and 13, I want you to write this down. For 10 and 13, I have a hint. So here's your hint. Solve for x under the square root. Solve for x under the square root. So what you're going to do is you're going to set whatever is underneath the square root equal to 0. That's not how you solve it completely. That's just going to give you a good start. So if tonight you get home, you don't have any idea what's going on, you can at least set what's underneath the square root equal to 0. Set it like 4 times. Cool, cool?
Yeah.
And let's go to the back. Or sorry, 18 and 19. I'll look it up before the end. Okay, number 18. 5 gold stars for anyone that can tell me what the name of that is. By the way, gold stars are not redeemable for anything.
Square root. Cube root.
Piecewise. Well done, man. Yeah. Well done. It is piecewise. The reason why it's called piecewise is we're taking pieces of different functions and putting it together. Usually they still remain functions. So as you can see here, we have a less than or equal to, and we have a greater than sign. They will not overlap at all. It's still going to be a function. Now to do this, we have to know what we're doing, like as far as graphing goes. So what kind of graph is x plus 2 squared plus 1? What kind of graph is this? Yeah, it's quadratic. What shape is quadratic? The U, also known as a parabola.
Parabola.
Yeah, good. Well done. What about this guy? 1/2 x plus 3.
Linear?
Linear. So what we're going to have is like a parabola and a line. And we're going to put it together and it's going to be one shape. Yes, ma'am?
Why is that red and yellow?
Because it's magical. All right. Which one do you want to do first, the quadratic or the linear? Quadratic it is. Okay. Anyone tell me my transformation rules and what that 2 and the 1 is going to make that do? 2, and when we say moves it, what do you mean? The parabola, and more specifically the vertex, right? So the vertex, instead of being at 0, 0, moves at -2 and then up 1. So my new vertex is at -2, comma 1. Now, unless you're really super duper awesome at quadratics like Alex is, you might want to just start plugging in numbers. So maybe first take an XY chart right here and plug in -1 for X. What happens when I plug -1 in? Well, we got your argument, PEMDAS and all that stuff. So -1 plus 2 is +1. +1 squared is 1. 1 plus 1 is, don't remember yourself? 2. So -1 comma 2 goes right there. Now, parabolas are symmetrical across the axis of symmetry. So since this one is here, I know that the other point is going to be over here. Good. Okay, the next one. What if I plug 0 in? What if I plug 0 in?
0 plus 2 is 5.
0 plus 2 squared is 2. 2 plus 1, or sorry, 4 plus 1 is 5. So at 0, comma 5, bonus question, do I have a filled in or an open circle right there? I know I have a filled in circle, is that right? Why? Because of this thing right here, right? Since it's or equal to, I can include that for my parabola, not for my line. All right, since it's symmetrical, I know that since it's over here, then it's also over here. 5 points is plenty for a parabola. Plenty. So let's go ahead and connect our dots. And then I'm missing one other thing. What am I missing on the end of one of these? An arrow. Which side? Your right or left? Left, right? Get it? Your left, right? Goes to the left because it keeps on going. Because all this says is less than 0. So we're talking about -10, -1,000, whatever. Hopefully yours looks a little better than mine. Now let's do the line. Where do I start? What's my y-intercept? 3. Do I put a filled in or an open circle? Open circle. And then Jake, what's the slope? My slope is 1/2. That means what? Up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And then what do I do? Connect the dots like we love doing so much. And probably should put something at the end of that. Little arrow action. Is this graph a function?
No.
People say yes, people say no.
Yeah.
Here's the defense for both answers. Well, number one, if I do the vertical line test, it's both points, not function. Right?
Right.
But only one's filled in. So this one's open. So if we draw a vertical line, it's only actually literally hitting 1 point. So it is a function.
I was right.
Alrighty, if there's nothing else we need to talk about this, let's go to the back. Are there any questions at all? What you got?
I'll harass you later about it.
Ask me later about it. Don't want to be recorded.
No, just don't care.
Oh, okay.
I just don't have you at the moment.
Alright, on the back. Gotta do lots of stuff. Number one, we gotta do an interval notation for the first top 6. On the bottom 6, we're doing inequality. Yes, you know what the difference is. Intervals using parentheses and exponents. Inequality is using less than or equal to sides. Alright, 1 through 6. Pick one and I'll do it. That's way too easy. 5 it is.
What about 6? No.
Alright, our domain. Where does it begin? Negative a million?
Yeah.
Is it infinity?
-5.
-7, cool. Bracket or parentheses?
Brackets.
Bracket. Comma.
Oh my.
1. Alright. Parentheses, bracket. Done?
No.
What now? 1 to 4, 3, what is that? 3, bracket, parentheses, bracket.
What's that U for?
The U is for a union,
Like marriage.
marriage. So what we're saying is that we're going all along here, cool, awesome. Oh, I got an open circle, so then I gotta jump up here, still got an open circle. That's why I do a union.
You talk about that?
I did. Sorry. Okay, range. Start at my bottom. -5. Bracket, parentheses.
Brackets.
Bracket to 2.
True.
Parentheses. Union or no union?
Yeah.
Union. And then I'm jumping up. I'm skipping 3. I'm going to 4. And I stop at, is that 6?
Yes.
Bracket. Alright, that's awesome, but that's not all we're supposed to do. We're also supposed to say if it's a function or not. So is this a function? Does it pass the vertical line test? Yes, it does. So it's a function. And the last thing we're supposed to say is if it's 1-to-1.
What is that?
So 1-to-1 means does it pass the horizontal line test? So if I were to draw a horizontal line, straight, hopefully, a little straighter than that, does it only hit my graph at one point?
Yes.
Yes, it does. So it is 1, 2, 1 as well. And all you have to do is, if it is a function, so if it passes the vertical line test, yes, it's a function, then do the horizontal one. If it doesn't pass the vertical line test, you don't have to do that. It means it's 1-to-1. That means there's only one x for every y and vice versa. It's like a super function. All right, are there any questions about that one?
Well, you right, you don't have, what if it pass, what if the function, because it doesn't pass the horizontal line?
Say not 1-to-1.
Okay.
All right, let's move on. Last 6, what you want?
11.
11 it is. That's been a very popular one today, and I don't really know why, but it's a circle weird. All right, domain. Where does my graph of my circle begin? Starts at 0, right? All right. We're doing inequality notation, right? So I should be using inequality, so less than or equal to. This x or y? X. What do we got again? Less than or equal to. Four. Cool. What about range? It's the same thing, isn't it? But what's the only difference? That's a y. Here's how that works. We went from our left side, 0, to our right side, 4. We went from our bottom 0 to our top that's almost 4. Good enough. Okay, does it pass the vertical line test? No, so it's not a function. And since it's not a function, I'm not going to even worry about whether it's 1-to-1 or not. Would it pass the horizontal line test either? No, so it's not 1-to-1, it's not a function. Awesome, cool, done. Questions about what my expectation is for you as far as domain range goes? No? All right. Let's stop.